Okay, hi, I'm Carla Westfall from Saddleback College, and this is a quick review of hyperbolic trig functions. I'm going to go over the definitions, the graphs, and how to evaluate them. For a while, it's going to be a little bit mysterious why they're actually called hyperbolic trig functions. We'll eventually get there, okay? But for now, just trust me, okay? We're basically going to build the first one, which we call cosh of x. That's hyperbolic cosine. So it's the symbol for cosine, COS, but with an H at the end, cosh of x. We're going to build it out of two familiar functions that I've already graphed here. So we've got our exponential growth function, y equals e to the x, and then we've got y equals e to the negative x, which is exponential decay. Cosh x, the hyperbolic cosine, is just the average of these two things. So it's e to the x plus e to the negative x divided by 2. That's the definition of cosh x. So if we look at what that graph is going to look like, I can sort of estimate the graph by just having these two things here, because cosh is going to be halfway in between the two graphs at all points. So it's going to end up looking something like this. In fact, one of the applications of cosh, it's a little smoother than that. One of the applications of cosh is that if you have a cable that you're hanging that's supported at 2 points, like here and here, the curve of that cable is going to be some transformation of the cosh graph. Okay. So a couple of neat things to see about this is y equals cosh of x, is first of all, notice that it's nicely symmetric about the y-axis. Okay. So this is what we call an even function. If I plug in opposite inputs, I'm going to get exactly the same output. And I can sort of see why. If I were to plug in 2, here I'd be putting a 2, and here I'd be putting a negative 2. If I were to plug in negative 2, here I'd have a negative 2, and here I'd have a 2, but it's the same two powers of e that I'd be adding and then taking the average of. So this is an even function. It's symmetric about the y-axis. Okay. Let's practice just evaluating this. If I wanted to evaluate this, let's try first of all cosh of 0. Now that one I can probably see from the graph, because both e to the x and e to the negative x had a y-intercept at 0, 1. So I'm going to get 1 and 1 and average them. I should get 1, but let's double check. So that would be e to the 0 plus e to the opposite of 0, which is still just 0, all divided by 2. And so that's 1 plus 1 over 2. Yep, that's definitely just 1. Okay. So the y-intercept here is 0, 1. Okay. If I want to evaluate it at another place, let's try cosh of natural log of 2. Because the definition involves exponential functions, the places that it's easiest to plug in are actually natural logs. So this is going to give me e to the natural log of 2 plus e to the negative natural log of 2 all over 2. Now, e to the natural log of 2, that's just a composition of inverse functions. So they undo each other, and that's just 2. We want to be really careful here. A negative power does not make the result negative. If we look at the graph of e to the x, that was this purple graph over here. That was never negative. The y values were always positive. A negative exponent means we're taking the reciprocal. So this is 1 over e to the natural log of 2, which we've just said is 2. So this would be 2 plus 1/2, all divided by 2, because we're averaging them. So let's see, that's 4/2 plus 1/2, that's 5/2, divided by 2, which would be 5/2 times 1/2, 1/2, which would be 5/4. You may see these this semester in a lot of integrals. If we're doing a definite integral, you might have some limits of integration that you have to plug in to your hyperbolic trig functions. That's where you're likely to be evaluating these things this semester. Okay. Now, it would just seem like there was something wrong with the world if we had a hyperbolic cosine and no hyperbolic sine. I mean, it just has to have a friend. So we're going to define now Cinch, which is the hyperbolic sine. And that really is how you say it. You say cosh and cinch. It's kind of silly. Okay. So for that, it's also going to be the average of two exponential functions, but it's a little bit different. I'm going to start with e to the x again. So that's just my basic exponential growth function. But instead of averaging that with e to the negative x, which I did here, I'm going to take the opposite of e to the negative x. So if I were to multiply this function by -1, that would flip it over the x-axis. And so I'd have something that looked more like so. So this is y equals the opposite of e to the negative x. And cinch is just the average of these two functions. So cinch of x is equal to e to the x plus the opposite, so just minus e to the negative x, all over 2. And if we take a look at that, again, we can sort of see what that graph is going to look like because it's going to be halfway in between these two graphs at every point. It ends up looking similar to a cubic function, although the curvature is a little bit different. Looks like cinch of 0 is going to be 0. Let's just confirm that. If I evaluate cinch of 0, that's e to the 0 minus e to the negative 0 over 2. That's going to be 1 minus 1 over 2. Yep, that's 0. And cinch, we can see, is symmetric about the origin, or it has rotational symmetry. If I were to turn this upside down, I wouldn't be able to tell I had done that. It would look exactly the same. Okay. So cinch is an odd function where opposite inputs give me opposite outputs. Cosh is an even function. And it's kind of neat because we built that out of functions that have no symmetry at all. And we get these functions that have some neat symmetry. Okay, so there are 6 regular trig functions. So there are 6 hyperbolic trig functions. I'm going to go over one more with you and then let you sort of figure out the formulas for the remaining 3. So the next one we're going to take a look at is tanh of x. You basically pronounce all of these by just putting a ch at the end of the regular trig name. And as you might guess, tanh is just cinch over cosh. But then I should be able to express that in terms of the exponential function. Because cinch, we said, was e to the x minus e to the negative x all over 2. And cosh, we said, was e to the x plus e to the negative x all over 2. Now that's a lovely complex fraction, but it's just this fraction divided by this one. If I flip and multiply by the reciprocal, those 2's are going to cancel. So we'll get e to the x minus e to the negative x over e to the x plus e to the negative x. And if we were to try to graph this, well, if I think about the end behavior, as we're going off to infinity, this piece and this piece on the bottom are essentially going to be going to 0. Because infinity, as we approach infinity, x is a big positive number, so the negative x makes the exponent big and negative. These pieces essentially become negligible. It's going to look kind of like e to the x over e to the x, which is just 1. And it does. So this one has a horizontal asymptote at height 1 on the right side of the graph. That's just an informal explanation of why that works. On the left side, if we're going off to negative infinity, Now that's going to make the exponent here and here positive, but these two pieces will have an exponent that's big and negative. So they become negligible, and this behaves kind of like the opposite of e to the negative x over e to the negative x, which would be negative 1. So we have a horizontal asymptote of negative 1 on the left side, and it turns out the graph just sort of rises between those asymptotes. All right, so there should be 3 more hyperbolic trig functions, and there are. So there's Cinch x, which is the reciprocal of cosh x. We follow the basic pattern established by our regular trig functions. We've got cosinch of x, which is the reciprocal of cinch of x. And then we've got cotanch of x, which is the reciprocal of tanch of x. So what I want you to do now is for these 3 functions, see if you can write down the formula for me, expressing these in terms of e to the x and e to the negative x. If you're watching this video at home, pause it, write those down. I'm going to turn off the camera and then turn it back on so that you can check your answers. Okay. And I think we'll wrap up this video after that. I haven't yet explained why they're called hyperbolic trig functions. We'll save that for the next video. Here are the answers, so go ahead and check your work.